Welcome back, everybody, to the California Small Farm Conference. My name is Evan Wigg. I'm with Community Alliance of Family Farmers, and we're very excited to have you here for today's workshop, Blending Habitat Conservation and Restoration in Ag Landscapes, from Research to Reality. So we've got some wonderful speakers here to join us today, some experts in the field and farmers. So thank you all so much for being here. It really means a lot for us and to our community for you to spend some time with us this afternoon. And for those of you watching at home, just want to encourage you to use the chat feature down below, as well as the Q&A if you've got any questions. And lastly, just a reminder that today's workshop is going to be recorded, and we're going to be posting this up on CAF's YouTube channel for later watching. And with that, I'll pass it on to you, Miranda. Thanks so much for being here.
Thanks, Evan. Thanks for having us. Good afternoon, everyone, and thank you for joining us today for this workshop. My name is Miranda Kirsten. I manage the Farmer Rancher Grant Program for Western SARE. SARE stands for Sustainable Agricultural Research and Education, and we support producer-driven research and outreach through competitive grants programs. And I can send out more information about this later today. Today, though, in this workshop, we're going to focus on some of the on-the-ground work. So today, I'm grateful to be here today with Jesse Trace and Alex Palmerly, both of whom have received funding from the Western SARE Farmer Rancher Grant Program, but their work, of course, goes so much farther than that. So I want to thank them both for being here to share about their projects and their experiences in conducting on-farm research and sustainable agricultural practices. So I'm going to let Jesse and Alex introduce themselves. They'll both share about their work, and then I will moderate the chat, and we will have time for questions at the end. So with that, Jesse, I'm going to pass it on to you.
All right. Thank you, Miranda. It's a delight to be here with the audience and other interested folks in learning about sustainable agriculture. My name is Jesse Trace. I have a background in sociology and sustainable development. I live on my family farm in San Luis Obispo County. We grow avocados, some subtropicals, and flowers, and we're expanding into a more extensive agriculture. So it's part of the work I do, and I also design agroecological landscapes and rainwater harvesting systems. And yeah, I suppose I'll just dive in now. Yeah, okay, great. So so I'm going to share my screen and talk about the Farmer Rancher grant that we successfully were awarded and developed. So here we go. All right. Yeah, so this project was titled Rehydrating Toro Creek with Sustainable Agriculture Traceland Farm Demonstration Project. We did it with the support of a local watershed nonprofit called Creeklands Conservation, the Western SARE Farmer Rancher Grant, and the family farms called Traceland, and it focuses on rainwater harvesting and oak woodland silvopasture. And this image is 1 year into the project, around March 2024. And that is a side view of this rainwater harvesting system that was developed thanks to these funds. So just to give you context of the region, um, Traceland is located in between Cayucos and Morro Bay. And San Luis Obispo County is directly in between San Francisco and Los Angeles. 18 inches of rain a year, semi-arid, so we want to capture as much of that rainwater as we can. It's green now, but it won't last long. And so that's a 9,000 acre watershed that we're in. And Traceland is an 80-acre farm, and it's only 1% of the overall watershed. So it's just a small part of it. And there were two main problems that we were trying to solve with this program. One is oak woodland decline. And essentially, globally, wherever oak woodlands are grazed in Mediterranean climates, they're in decline, as well as locally in Northern California. And so, trying to find a way to restore oak woodlands and graze at the same time. And you know, um, often food systems kind of ignore the broader context that they're developed in. And so biodiversity and ecosystem services were really front and center in developing this system, because of the cultural supporting, regulating, and provisioning benefits that come from ecosystems and working to reconnect the food web on the landscape as we bring grazers back into the picture. We took them off for several years. So and we focused on the oak woodland ecosystem. It is the most biodiverse of all the ecosystems in California because the oak tree is a keystone species. It has, hundreds of terrestrial vertebrates, over 1,000 native vascular plants, fungal species, and arthropods. So it's very much a a keystone species for other wildlife. And then there are endangered species that are also affected um, by large grazing systems, and the lack of water and trees in the landscape, specifically the California red-legged frog, and steelhead trout, just to name a few. And California is part of a global biodiversity hotspot. It's called the California Floristic Province. It starts at the top of Baja and goes to the bottom of Oregon. And there's just tons of endemic species. And so just taking a look at San Luis Obispo, you can see that there are all these hotspots. Where we are, there aren't as many, but we're still part of this mosaic. And honing in a little closer on our region, I wanted to highlight this article. It's called "The Late Holocene Human Environment Interactions on the Central California Coast, USA, Inferred from Morro Bay Salt Marsh Sediments." And essentially, what that means is that sediment cores in the local estuary were extracted to determine what did the landscape used to look like. And what you can see here is essentially a time machine, and you can go back to about 800 AD, all the way to 2000, and you could see the different pollen zones to determine, what were the plant species that were on the landscape. When it rained, their pollen was swept into the estuary and out to sea, but it was, in sediments trapped. And so you can take out these cores and you can take a look and see what the landscape used to look like. And what we can see is that when the Spanish missionaries arrived in 1770, there was a precipitous decline of tree species, and really just a lot of changes going on. And if we look closely, we could see that Quercus, which is our oaks, decreased substantially and are at about 1/3 of their original distribution. So this is, just evidence that the watershed used to have more oak trees, and now it doesn't. And a big part of that is because of the grazing that's taking place. And I know my colleague is going to be talking about that next. So this is just another result of land use and land cover change. This is a historical map of the Morro Bay Estuary from 1897. And then you can see from 2017 now that the essentially the erosion from the watershed has almost doubled, and that's increased the salt marsh. But because of our land use practices, there's a lot of erosion and sediments in the estuary, which used to be more freshwater. So, this just all speaks to kind of the problems of our current food systems and what some of these externalities are. So the final thing, this is Mark Shepard in the frame there in his silvopasture system that he developed. But 1/3 of all food in the U.S. is wasted and goes to landfill. So if we were to have a more efficient food system, we could take 1/3 of that space and we can turn it into wildlife habitat. Imagine what the landscape would look like. And the second thing is focusing on groundwater. Groundwater is key for farming in the arid West. And this is a chart of the Paso Robles groundwater basin. It's in SLO County, and it has continued to be overexploited. And that stock market crash red line there is what's happening as more and more pumpers take more water out and not enough comes back in. So how do we restore the aquifer while we're producing food? This is a chart from Tending the Wild by MCAT Anderson, and it just shows some of the remaining area of ecosystems. The best ecosystems have been replaced with urban landscapes and farming, and so there's just about 10% of the original riparian woodlands left, 10% of the freshwater wetlands left, and a lot of these ecosystems have been disappeared. So how do we bring them back into our food systems? Just a high-level timeline on how I ended up developing my thinking. I ate acorns for the first time in 2019. I thought forever that you couldn't eat them. It turns out you can, and they're delicious. And then 2020, around the same time as the pandemic, had a lot of free time, read Restoration Agriculture, harvested acorns. And then by 2021, I did a permaculture design course to kind of understand a broad landscape design. 2022, applied for the Western SARE Farmer and Rancher grant, was awarded that, started growing oak trees and walnuts, which I determined were the best species for the region. 2023, I developed the earthworks for this rainwater harvesting system, and by 2024, I'd successfully grafted some oak species that have a lot of great qualities for agriculture. So that's kind of the high level timeline and kind of the problems of what brought me to this. And so again, the title was Rehydrating Toro Creek with Sustainable Agriculture, Traceland Farm Demonstration Project. There were 6 objectives. One was water management accounting, so understanding how much water we use on the farm. 2, expanding agriculture onto the flats, restoring the habitat and doing the earthworks. 3 was reduce erosion and arrest stream bank collapse, which was a problem from the land shape. 4, capture 500,000 gallons of stormwater runoff. 5, biosequester CO2 from the earthworks in tree planting to kind of neutralize the impact. And 6 was research and develop acorn food production. So objective number 1, water management accounting, essentially with broad strokes here, kind of determined what the acre feet per year is we're using. So you could see the little home there is the homestead. The average homestead in California uses about an acre foot. Our flower production is about half We have a home orchard, and we also water the dirt road by our place so that there's less dust in the air, which can are problems for certain pests in the avocados. And then you can also see the addition 1.64 acre feet, and that's from the rainwater harvesting system. So overall, we have roughly 8.5 acre feet per year of water use for our operation. That's going to change when we start to bring grazers back in. This is the kind of minutia of determining all of our water use, but essentially avocados use the most, then our other subtropicals, and then in some cases the restoration plantings will establish them and we'll be able to take the water off, and they'll actually be a water source, and will capture and produce water through evapotranspiration. Um, yeah. And then, yeah, objective two. Objective two was to expand the agriculture. So you can see in this image here, expanded our flower production. It's next to one of the basins here that I'll talk about in a minute, to restore habitat and to develop the earthworks. So the bottom right image is some folks from the Resource Conservation District and some other volunteers that helped us plant out this giant hedgerow that we did, and just some images of fauna that have been showing up when water returns to the landscape and has time to sink in. So this is a Western chorus frog and a killdeer and some other fun stuff showing up on the land. And so before we developed the rainwater harvesting system, I wanted to get a sense of the baseline. So I've spent the last 4 years taking a picture of everything I could that was new, from birds to grass, flower species, you name it. And so I've got about 107, 105 species, 107 observations. Some are the same, just to see how things change as the water and trees come back into the landscape. So we shall see. Um, and and yeah, so determining what to put on the landscape was based on the ecosystem, right? What is going to do, what is already adapted to this space. And that's what the Restoration Agriculture book tells you. So you identify your biome. In this case, we're a coast live oak savanna. Then you identify the interesting edible genera. So we've got coast live oak and other oak species of Quercus. Prunus are stone fruits. Sambucus are elderberry. Vitis is grapes. Amelanchier in the apple family. And juglans are walnuts. So all of these will establish and do well over time, and not need any water. So it'd essentially be a dry agriculture. So this is the conceptual design before we did the earthworks. More or less, we're able to fit 9 berms and swales. We removed some since then, and also changed the plant palette a little bit, but that's kind of what it was supposed to look like. And the spacing was based on a mature oak tree size of about 80 foot diameter. So that's room for all of them to grow up with 30 to 40% canopy cover, so that grazers can still eat grass. The benefits of oak trees are innumerable. Here's just a few of them here: mushrooms, drought tolerance, habitat, firewood. So bringing them back into the landscape is really important for all of their byproducts. And in order to determine what else was missing from the landscape, from the biological baseline, I went to CalScape and clicked on where the farm is and found all of these species that it recommended, and many of them were not there. So it was pretty easy to return them to the space that way. And these are the ones that I picked for a conservation hedgerow, or what we've now renamed as a native plant and food pollinator hedgerow. And essentially, yeah, coast live oaks, golden chinkapins. All of these have edible nuts or berries. Serviceberry, wild grape, blue elderberry, just to name a few. And this is what the conservation row will look like when it's mature. So had the trees on 25-foot spacing with the shrubs under them to kind of have strata of a forest. This is going to be the most intense planting, and then everything else will be much more extensive, but it's also an attempt to reintroduce the seed source. So the bottom most of the nine berms and swales is the one that we determined to be the native food and pollinator hedgerow, planted over 400 plants with the help of the local RCD. And this is what it looks like today. So we've got some irrigation on it for the first several years to establish everything, and then we'll take it all off. So sages, uh, gooseberries, walnuts, all different kinds of things are going back into the landscape, and they are going to be outside of the grazing, just because they probably would not do so well unless they were really well protected. Objective three was reduce erosion and arrest stream bank collapse. So there was one point, if you could see the natural water flow, that was going directly towards a cliff edge on the creek, where the creek is meandering and eroding a bunch of bank. And so essentially what we did is we still hadn't dug out the berms and swales there, but you could see where they're going. And we shunted the water from one of the two drainages into the other one that has an armored spillway and an energy dissipation bowl, so that during a high flow events, the energy will be dissipated and it'll be sent back into the creek. And this is at the bottom of the entire system, which was actually originally the dump of the old landowners. And there's car chassis and all kinds of stuff to stop erosion in there. And so we dug it all out, removed some plants, and filled it full of rock. And so it will no longer erode when there are big rain events. Objective four was to capture 500,000 gallons of stormwater. That was kind of an arbitrary number, but just getting a sense of, what the volume was that we could capture, um, depending upon the size of the system. And so this is looking west over the rainwater harvesting system. This was the most full that I had seen it ever, and since then we've touched it up a little bit. And so this design was based on keyline water management. It was developed in the 1950s by Percival Yeomans, and later expanded upon by his son Ken, and then developed by Mark Shepard, who developed restoration agriculture. So I used those concepts, and essentially in designing your landscape or your farm, you use scales of permanence. On the y-axis is the more difficult things to change that take more energy, and on the x is relative permanence on the landscape. So, and the top right, then you have the climate, which is very hard to change. It takes a lot of energy and it lasts the longest. Then is the land shape, then how water flows on the land. So when you are developing your space, you want to focus on the things that take the longest and are the hardest to do. And then as you go further down, you have your roads, your trees. So you don't really want to place your trees until you've shaped your land in a way that works for your operation. So there's kind of four basic steps: observing the landscape, understanding your slope, inf knowing how infiltration works, and getting your evaporation rate for understanding water. And this is just a rice paddy system, which uses contours to safely convey water. So this is the system seen from kind of the southwest So the other view was from the top right here, looking west, and you could see we have 14 basins. So 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, 12, 13, 14 here. So there's essentially two drainages. One, two. Got three ravines. The third ravine used to drain this way over to this edge right here. But we sent it into this drainage, and then it goes to here and then down into this energy dissipation. And then we've got 9 berms and swales. So this is the one that we developed for a native food and pollinator hedgerow, and then the rest are going to be like an oak woodland silvopasture. So the fence is going right here, which you'll see later, and the cows are going to be grazing about 55 acres. Um, yeah. So slope essentially you don't want to be capturing water over 10% because the erosive force 10% slope of a landscape because the erosive force becomes really powerful and it's very hard to control and there's more variability. So our entire flats were maybe at a 1 or 2% slope, so it was pretty easy for us to work. Um, the second thing is runoff, and that's based on uh, key line design. This is a group called Regrarians out of Australia, and they have kind of three main criteria. One is the average rainfall, two is the total evaporation, and three is your type of soil. So here's a chart here to determine kind of where you land, where your farm lands. And so for us, we have a clay, inelastic clay, with very little infiltration. We have quite a lot of evaporation because we're semi-arid and we get between 18 and 30 inches of rainfall. So we were able to determine kind of how much water would stay on the land and be able to be detained through our landscape features. And then just next canyon over is a big reservoir, and they have uh, average annual pan evaporation at 65 inches. So that's greater than our deepest basin. So in other words, even if we were to capture everything, fill it up all the way to the top by the end of the year on an average evaporation, all the water would be gone. That's if none of it was infiltrated into the ground. So this is very much an ephemeral water capture system. So water by June, July is already all gone on the landscape. And these are kind of the dimensions of the system. The runoff calculation on the left that I described a little bit. The sediment basins, we've been calling them because they also capture sediment that's mobilized from runoff. So it's 14 basins and then 9 berms and swales, and collectively it's about 500,000 gallons or 535,000 gallons of volume. Here's an image of the flower basin, we're calling it, and it's about 30 feet wide by 100 feet long by about 3 feet deep. So that was how we determined our dimensions. And then this is a Berman swale, which we dug originally, and after we looked at it for a while, realized that it was too steep of a dam wall, so the left side, and that the cows would really erode it. They would erode it down into the bottom, and that would reduce the volume. So we ended up changing that and developed a much shallower system. And you can see the cows in there browsing. Yeah, and so this is after capturing water for a year, we realized that in fact we're capturing a lot more than we had originally thought. So it's about 42 acres is the size of the whole watershed. The bottom two basins capture a lot of runoff from the avocados, which is a big sponge because there's tons of mulch and we're also watering, so captures much more. It sheds much more water than we can capture in these bottom two basins. But the upper part of the watershed really is a big sponge. And what we found is we were able to capture everything from a rain event. So it's a little less, I'd say it's about 25 acres of watershed that are above kind of what drains into these two basins. So this is the Flower Basin, this is the Redwood Basin. A lot of the water drains into these and spills over. But the rest of the system, which is 12 basins, captures the majority of these three ravines that drain down into here. And so, in the 23-24 winter rains, so last year's rains, we had 24 inches of rain. That's about 30% above average rainfall, and the entire system did not spill. So if it had spilled, it would have spilled from this basin down into here, and then into this, and then out into the creek. But it didn't spill at all, which means that every single drop that hit the land in that area was captured, uh, which is uh, which is a successful project. Um, Objective 5 was biosequestering CO2. So, thinking using native analog plants. I've developed a nursery. I've got walnuts, oak trees that are being grafted there, mulberries we're working on growing. And give or take, because of the earthworks and the CO2 that was emitted, it was about 72 tons of CO2 that was emitted from the project. So in order to capture that, we needed to plant 72 oak trees. Each one captures about a ton of carbon at 20 years. So if you plant 72 oak trees at 20 years, you've captured all the CO2. However, these trees will live for centuries. So really what we've developed is a food system that produces that is a huge carbon sink. And that's what we know from our oak woodlands. And this food system is going to be more of a clonal propagation bank where we have unique elite oak cultivars that we can then take from and graft and plant elsewhere. But it'll certainly be producing acorns that are edible, some right off the tree, others need to be leached. But yeah, and so this is an image of the second berm up from the bottommost berm where we've been planting oak trees in cactus tree protectors, which is an innovation from Spain that is just excellent for protecting trees and grazed rangelands. And learned about that during this project. Um, and yeah, and this is the CUFR tree carbon calculator is what I use to determine the CO2 carbon capture rate of both the home oak Quercus ilex and the coast live oak Quercus agrifolia at 20 years. And finally, objective 6 was to research and develop acorn food production, which I've done over the last several years, made great relationships with folks in Spain and Portugal, as well as here locally on our native species, which are have great promise. And yeah, looking forward to planting those out and grazing. And so here's an image of before and after of the project. On the left is 2017. They're not perfectly aligned, but and then on the right is last year in March with quite a lot of water in the system. And that's all. These were my references.
That was great. Thank you, Jesse.
Thank you, Miranda.
Very inspiring. Uh, Questions for Jesse?
Sure.
Now Alex can get his slides set up.
Okay.
So first, we have one in the chat. Is there a solution for black walnut disease?
Great question. I think at this scale, Yeah, I'm not qualified to answer that, but there are issues with oaks as well with sudden oak death that really need to be addressed to have sustainable nut crops.
And then we'll do one more. Do you have any issues getting your county to permit the swales? Someone's designed infiltration swales for my very small 9-acre parcel, and the county is having a hard time understanding that the swale design could work better than their typical storm management.
Right. Yeah, we were very careful about reading the grading permits and using agricultural grading exemptions. So, there's a way to kind of skirt the regulations respectfully in order to do it. And we were able to develop this proof of concept, which normally wouldn't have been possible had we um, asked for permission.
Thank you. Um, But Jesse, I encourage you to get in the chat.
Okay,
There's some good
great.
feedback for you. And Alex, why don't you tell us about yourself?
All right, thanks, Miranda. Welcome everybody. Thanks for having me. My name is Alex Palmerly. My family owns Farview Ranch, which is a 1,000 acre cattle ranch in Butte County. And I've also been doing habitat restoration on private ranches and farms for about 25 years. This project that we worked on with the Western SARE program started in 2023, really looking at the issue with blue oak, specifically Quercus douglasii, which is sort of the cornerstone species of a lot of cattle ranches in that first what's called the bathtub ring around the Central Valley of California. You'll notice on a couple slides that the publication that came from this research is linked below. Either you can click on that to link to it, or just copy it and find uh, the full article that goes through all of the details. I'm going to kind of paint with a broad brushstroke through this presentation. So, what's the trouble with oaks? For years, there's been a lot of concern about oak recruitment in general, many species of oaks, not just the blue oak. Um, and a lot of the research has been very mixed. Some studies showing that cattle are very detrimental to oak recruitment, and other studies that show that zero grazing, taking cattle completely off of the landscape, is not always a viable solution because, and we've experienced this on our ranch through some of the restoration projects that we've done, when you take grazing away, the annual grasses that build up over time create sort of this like cardboard, almost impenetrable thatch that is both difficult for acorns to make soil seed contact, but also harbors a lot of the pests that are then have safe haven to roam under there. So we've had 5-year-old beautiful oak trees that were on irrigation and had protection and no grazing that just overnight turn brown, and you can pull them out of their tubes, and there's just little gnaw marks on the bottom of the around the base of the tree. So there hasn't been sort of a conclusive study that said, look, this is a crisis. We need to get cattle off the landscape altogether. That's the solution. The other issue is that blue oaks themselves are extremely long-lived. They're slow growing. So there's been a hesitancy in the scientific community to make big claims, sort of this thought that these are a species that need sort of this perfect storm of a big rain year matching with a big mast year with a fire that went before, and the pronghorn antelope didn't come through that area that year. And so people have sort of been hesitant to say that this is a real problem. There's a lot of anecdotal evidence and a lot of people just on the ground feeling like, well, something's definitely off here. So, we've been doing oak restoration for a long time. Oak restoration itself has, by a gentleman named Doug McCreary out of the Sierra Foothill Research Center, specifically working with blue oaks, has really been brought down to a science. What we wanted to look at with this survey was, there are areas on cattle ranches where you find natural recruitment, that is, blue oaks that are recruiting alongside cattle ranching. So we wanted to look at a ton of ranches, find these places where oaks are recruiting naturally, talk to these landowners, measure a bunch of the factors that are known to limit recruitment, and try to figure out if there's, some patterns that would emerge. So we were looking only at cattle ranches, not ranches that were grazing with other species, below 1,500 feet north of the I-80 corridor, and landowners needed to be willing to share their management details with us. Farview Ranch is right in here, which is, all of our neighbors, which is why we have a big grouping around there. So we were looking at four classes of recruits. There's this smallest class, class one, where they're sort of under that 4-inch mark. And these are really common to find on the landscape. You can walk around one year and just think, man, we don't have any problem. We've got so many oaks coming up, and you can come back 2 years later and there's no oaks. There's this middle class, and then this third class, which you can see my colleague here standing next to a 2-meter tree. And really that third class is what is critical, because at that point they've sort of escaped browse pressure from cattle. This middle class is really concerning because this individual has been caged, but you can tell all of this growth. This is a very slow growing tree. All of this growth has died off. In some cases, you can see it's been broken off, and there's been resprouting. So a lot of this response is almost as if a fire had gone through and top killed these trees. So in a sense, they're sort of constantly getting top killed by browsing, especially these middle size oaks, because they're right at belly scratch height. So a cow can literally straddle that tree, rub up against it, and scratch its belly for any number of issues that, ticks and all sorts of things. So some of our findings, one of the main findings that we had of all the things that we looked at soil type, we looked at native versus non-native cover, we looked at proximity to mature trees. One of the only statistically significant things that we found was there was recruitment occurred more frequently in rocky areas. So that there could be any number of reasons for that. These acorns are cached by all sorts of animals, so it could be that caching sites are preferred around rocks, and so therefore they're more likely to occur around rocks. Could be that there's increased water infiltration around rocks. We don't know any of that. What we do know is that one of the measurements we took was we did a dung count around these areas where we found oaks, and then we paired that with, we did all these measurements in areas that had recruiting oaks, and then we found the closest area without recruiting oaks and repeated all those measurements. You can see us flagging every dung spot we could find. So we're out there looking for individual bowel movements. If we could determine that one bowel movement, cow walking through the landscape and dropping several patties, if we made that one bowel movement, then it was only counted once. So dung counts were also significantly lower in rocky areas. It sort of makes sense. If you're a cow, you're not going to want to bed down in those areas. Certainly, you're not going to spend as much time in those areas. Do we know that? No. Is it Is it an interesting combination of factors? Absolutely. So the other thing that we did that really brought some tremendous results was that we did destructive samples at every one of our sampling locations. So we ended up with 60 sampling locations on these 20 ranches. So 60 areas, sort of unique areas where oaks were recruiting, and repeated those same protocols at every spot and at 60 places without oak recruitment. And so we ended up doing these destructive samples, which means that we killed the tree. They may sprout back, but we cut the tree down at its base, right where it meets the ground, to be able to age these trees. There's a lot known on the dendrochronology on mature oaks is pretty advanced, but there's very little knowledge about how old these trees actually are. And so the key finding from this part of the study was that these small trees that many landowners assume are young trees and are therefore evidence of healthy regeneration, they're not necessarily young at all. Most notably, you'll notice that we had a 17-inch tall tree that was 64 years old. So you see that in the middle. And then when you play that out across the different grazing regimes, so right, we did all these landowner interviews, figured out in this pasture where we found these oaks, when do you bring cows in, when do you bring cows out, how many head are you grazing in there, and how many acres is that field. We were able to come up with a grazing score and then rank those properties by their grazing intensity. So under heavy grazing, these oaks are growing in height 1.2 inches per year. In the worst case scenario, so that individual that was 64 and 17 inches tall, they're just passing a 1/4 inch of vertical height per year. So actually, after this study, we went back just this last year and we said, okay, so these are subprime conditions. What would, if we take a quick snapshot of what really good conditions would look like? So we went and found areas that don't have cattle, that maybe are on a roadside. Often you find oaks recruiting on roadsides. Roadsides are complicated because there's weed management and there's increased water because of runoff, surface runoff. So we didn't use that at all in our study. But just to get a sense of, how quickly can a blue oak grow? So we cut down 20 oak trees at 2 ranches. Don't worry, these are surrounded by like hundreds of other recruits. So this is a light thinning of the stand. So you can see there you're over 4 inches on average and 8 inches per year in the best case scenario. So what this means is that if we look at how long it would take for one of these oak trees to escape that browse line, that to reach that 2-meter height where they're no longer able to be impacted by cattle grazing, you'll see that in that highest setting, it's going to take 800 years. Pairing our worst growth rate with our worst ranch, heaviest grazed ranch, it's going to take 800 years for that tree to make it to 6 foot tall. So the concerning thing about this is that we're sort of looking at the evidence that we have on the landscape is that, well, maybe there's some areas where oaks are recruiting, and so maybe it's not that big of a crisis. Except that if small trees can't escape grazing, then they're essentially like a zombie generation of oaks. That if they take 800 years to reach any sort of reproductive maturity, they'll be dead for a long time before they would ever reach that size. So that for us is a real alarming fact. And so then, so those are the main takeaways from that study. And now we're interested in, okay, well, what can we do about this? When we're looking at cattle ranches, we're often sort of trying to balance between management and restoration. So management, just to throw this anecdote out there, we had one rancher in Yolo County who had two ranches about the same size and about 2 miles apart. They were each about 2,400 acres, so they're not small ranches. Managed very differently, but by the same landowner and essentially the same landscape. One had been rested for 40 years in an NRCS program called the Conservation Reserve Program. And then since the end of their agreement with NRCS, they've only grazed it 1 out of every 3 years. On the other ranch, they grazed with what has become quite a popular regenerative grazing practice, which is that they did high intensity, short duration grazing. That ranch was divided into like 18 sections. They moved cattle through there quickly, and cattle only spent one grazing event per year, high intensity, low duration. That second ranch with the rotation had no oak recruitment anywhere. It was one of the worst ranches we found. We struggled to find recruitment areas. That first ranch is pictured here on the bottom left, and there was oak recruitment everywhere. So it does suggest that somewhere there is a Goldilocks level of grazing. Now, is it economical? Very likely not. But are there cost share programs that could be geared toward incentivizing alternative grazing? Absolutely. We would need far more evidence-based research about sort of what exactly that fine tuning is. The thing that we're really keyed on right now is doing a caging project. We have another Western SARE grant out now. It's a great program. You should look into it. So you can see on the right here, this is an example of a cage that we've built using sturdy hog paneling and 2 T-posts. If you've ever worked with cattle and tried to protect them from plants, field fence, any kind of light gauge wire is not going to work. They will just push in just to get to that grass. They're not necessarily trying to graze the tree, but they're also just scratching. So anything you put out there that they can use to scratch, they will use. They're huge. They bend things in. And so you really need to build something that is very strong. So these are some cages that we put out on 2 ranches on either side of the valley, and we're measuring their response to this this release from grazing. So essentially what we've done is we've taken these and taken the grazing off, but just in that one very condensed area. And the assumption is that we would see a huge response in vertical height growth because they essentially have mature root systems, and their above ground material is sort of not able to express itself because of the grazing. So, we'll see how that works. We're trying to do a statewide project to see if caging is effective so that some of the cost share programs, the Healthy Soils program, EQIP, some of these other cost share programs that are available to landowners could adopt that practice for California rangelands. So the other side of this manage or restore question is restoration, something that I've been doing for over 20 years. You've got lots of different options. essentially the more you do, the more success you get, but the more cost you have. So a lot of my concern has been how to balance that cost and the return on your investment. Um, the deal breakers are really for in our area where we don't get any sort of coastal fog in the summer. You have rock hard soil. We need irrigation. We need tubes, and they can't have any cattle access. And by that graph you saw, we're talking about best case scenario. We're talking about 10 years of cattle exclusion, more likely 20. So the standard model, I will just send a shout out. These are students from the Center for Land-Based Learning SLUES program, which is a statewide environmental education program that brings students out to private lands to do habitat restoration. So it's a great program. We've been working with them since 2005, and it's just been a great experience. From a restoration standpoint, keep it straight, keep it simple, straight lines, good fences. We disc after the first inch of rain to kick back that first flush of annual weeds, which in our area, because it's so dry, I mean, we get up to 40 inches of rain a year, so we're on the wet side of the valley, but the soils are poorer than, say, the valley. If you had a farm or a ranch in the valley, you'd be looking at much more intensive weed control. And then we're, collecting acorns in the fall, about September, October, planting in December after that soil has been saturated. We do irrigate, as I said, and one of the keys for us has been to bury the drip line. This is critical for the voles that I mentioned before, ground squirrels, any of these chewing rodents that in the middle of the hot summer, it's almost like they can smell the water in the line. Just burying your drip line like an inch or two under the surface has sort of reduced our irrigation, the amount of time that we're spending fixing irrigation line in half for sure, if not more. This is a little irrigation spooler that we built. It's just an office chair turned upside down with a 20-gallon planting pot wired to it, some PVC to extend the arms. You put your roll of drip line on that. And even if you're not burying your drip, if you've ever unspooled a 1,000-foot roll of irrigation, you can get yourself in a mess really quick without a spooler. This is actually, we did another SARE project where we did an experiment with drill seeding blue oak acorns. So we built this, essentially this acorn drill seeder, which is just a simple shank attached to the equipment bar for a 3-point hitch, put a 2-inch pipe behind it, and you can I'll show you this video. It shows you how it works with irrigation, and you can just imagine that instead of the line, it's acorns being dropped in there. It's my brother and my son. All right, so here at the bottom of the page, you're seeing the irrigation is on the spooler way back in the background. It's going into this tube at the top. And then down at the bottom, there's this steel shank that's stuck in the soil, and it's sort of cutting open this furrow. And then as the implement passes, the soil just kind of falls back down over it. So it's the same thing with the drip line or the acorn. The drill seeding worked tremendously well as a technique. If we were to do it again, we would need to follow this up with irrigation and tubes. What we found from that study was that there's just almost zero survival without that. You can see in this image down here, once the line is buried, you can you can either buy line that has emitters built into it that are on, either 2-foot centers or 4-foot centers, or you can even get them specially built. Or you can, individually place your emitters. You dig down, find the line, put the emitter in under the soil, and then add a piece of the spaghetti tube on top of the emitter so that even if a rodent does come along and nibbles at the end of this spaghetti line, they get to the soil and then they stop, and you still have your pressure is still intact. So this is a picture of Farview Ranch from above, my family's ranch. You can see on the eastern side here we have nice, healthy blue oak woodlands, albeit without natural recruitment. And then on this western part, we have about 400 acres that in the late 1800s, early 1900s was cleared. The valley there were no levee systems in the valley, and so that was sort of the best farmland in the state. So what do you do across 400 acres to restore that to what you might call sort of a pre-settlement scenario would be extremely cost prohibitive, fairly unrealistic for most landowners. So we are currently in the middle of this project that has fenced off using 2 different methods, again with this heavy duty steel paneling. These are 16-foot by 50-inch panels. We have 10 of these replicates of this smaller version, where Jesse would be proud. We actually built a berm on the downhill side for some passive rainwater collection. And then these bigger exclosures with 4 of the 16-foot panels. We had 5-gallon buckets and irrigated it using these fabulous IBC totes that, thanks to the marijuana growing in our region, have become very easily accessible and quite cheap. Some of the trials that we did during this project was this concept of deep watering. When you do drip irrigation, obviously it's watering on the surface, and drip irrigation is great, just delivers water right to the plant. But we wanted to take that a little further, especially for this scenario where we're just trying to get sort of islands of blue oaks reestablished on the ranch. So we took this old drip line that we have miles of, and just cut, maybe a 2-foot section, buried it in the ground before we planted the acorns, filled the soil in, planted the acorn, tubed it, and then that line just got plugged right into the 5-gallon bucket so that the water is being delivered about 12 to 18 inches down, sort of where the roots actually are, and not evaporating on the surface and running off as you try to fill it. We shaded half of them to see if shading was a key part for success. And then we collected cow poo for a couple days and made a slurry. If you've ever been on a cattle ranch in the summer, you can walk around, and anywhere there's a cow pie, it's like the best weed control you can imagine. It's just this hunk of cardboard that nothing can grow through. So we rehydrated that cow manure and put it in a slurry around the plants. You can see it, where is it? Right here, around this plant. That's that cow manure mulch. And that was extremely effective as a mulch and as weed control. So being prepared for the worst, midwinter droughts are super common now. We've always had them, but they've always been like 1 to 2 weeks. The midwinter droughts in California are getting more extreme now, as many of you will have experienced. You can have bad masting years. Oaks are a masting species. You can have 0 acorns one year and hundreds of thousands the next. And then last year we had the worst grasshopper outbreak I've ever seen. These are our projects from last year with grasshoppers that yeah, they were terrible. We had out of 200 of these oak plantings, we have 6 that made it. We spent a lot of time going to Walmart and buying pantyhose, as you'll see here on the right. And those worked really well, but if they got a slight tear, the grasshoppers would get in, and once they got in, it was done. Um, so after that experience, this year when we went to replant it, we decided to take half of those 16 foot by 16 foot plots, and instead of planting them individually and saying these little acorns in this little tube, we mass planted in half of the plot, and we will protect the seedlings when they emerge, and hope to be able to test that planting technique. So that's it. One of the things that we really try to do, whether it's on my family's ranch or on our other projects, uh, is to plan our restoration projects so that they can tell a story. And really, all that means is that you just need to count. Count how many you put in, count how many survive. If you're gonna treat some way and some the other way, just count how many you treat that way. I have other ranchers that are hesitant. They really want to do projects, but they don't necessarily want to get into the science. And when I tell them that all you have to do is count, it sort of takes some of the pressure off. So that's it.
Thank you, Alex. That was wonderful as well. There's a comment. Someone might try the deep watering technique. We have a few questions for you. The first is, were you able to account for deer browse in your site comparisons?
No, that's a great question. Um, Although, we don't know how deer populations fluctuate. Some ranches certainly have higher deer populations than others. But what is certainly true is that after, most of these ranches, the cattle leave, the cattle are not, in fact, none of the ranches that we were on had cattle year round. That's pretty typical for most ranches in that area. It's just too dry. There's no food. You'd have to hay all through the summer, which is cost prohibitive. So most of the cattle are shipped either to mountain pastures in the Sierra or to irrigated pasture in the valley. And so after enduring, November through May, sometimes June with cattle, then yes, you're the only green thing on the landscape and you have a ton of deer pressure. So no, it doesn't account for deer. Are they part of the story? 100%.
Thank you. Could you please repeat what happened with the Conservation Reserve Ranch? Was it grazed and how?
Yeah, so that conservation reserve grant, that ranch, so they did not graze. So they were dry land farming for wheat, and so they were plowing the tops of their hills every year to plant wheat, winter wheat. And NRCS has a conservation reserve program that'll pay you not to do that. And so they did that for 20 years, no grazing, no tilling. And then after that 20 years, they brought cattle back into that area, but they only grazed once out of every 3 years. So 2 years of rest and then 1 year of grazing. And even within that 1 year of grazing was limited to I think 127 days of grazing. So short season and only 1 year. So yeah, I mean, if you have a ranch and you can spare 10 acres, just, try it out because we definitely need to sort of toy with those. There's also a question of timing, right? blue oaks are deciduous, so they're dormant during the winter. So conceivably, this time of year, you could be ending the grazing and then allowing them to leaf out and do their growing season without being hammered by cattle.
So, so with the oaks, why do you plant acorns and not more established
Yeah,
seedling?
great question. So actually, the research that I did for my master's program back in the early 2000s was looking at the cost effectiveness of planting container stock versus planting directly from seed. Container stock has a lot of issues. There's Phytophthora is now a huge concern for spreading sudden oak death and that surviving in nursery systems. It's expensive, they're $9 a pop now to get a container plant. But really for oaks, it's more just that. So an oak is a tap-rooted species. It sends down a root about 18 inches long in the first 4 months. So the oaks that we planted this December are already down well past where a even the deepest sort of container plant would go. And so what happens to that taproot is it gets to the bottom of the container and then the air prunes it off. And acorns actually, the acorn planted plants actually catch up above ground. They catch up with the container plants pretty quickly. Um, I think there's of course there's room for to look at things again. We certainly, especially with valley oaks, which do tend to transplant a little bit better than blue oaks, we will certainly, to sort of hedge our bets against a bad masting year, we will pot up acorns from a good masting year, particularly of valley oaks, just as a safeguard for the next restoration season.
Thanks, Alex. Since we're talking about planting oaks, Jesse, there's one for you. Why do you graft the oaks, and which species do you use for grafting, and why?
So there's an image of a 200-year-old massive tree in this island of Mallorca, 3 foot wide diameter, and it has a graft scar across the whole thing. Um, every commodity fruit or nut essentially is grafted. The Hass avocado came from one original plant in the back of someone's house in Los Angeles in like the 20s. Genetic diversity is important, and we should definitely also be planting in seedlings. But everyone wants, if you want a Fuji apple, you graft the apple tree. So if you want an elite oak cultivar, and Spain already has some, the United States has some, California does not yet. So I think we're going to be doing a lot in the next, I don't know, several decades to develop our own cultivars. But you can get a superior acorn, whether it's an almond or whatever it is, it's grafted, and that ensures that it's a genetic clone.
Yeah, I suppose it also depends on your purpose for planting the oaks on what method you might want to use.
The purpose is, in this case, is for eating the acorns, which is something that's done, but it's not very common in California on the whole.
Thanks, Jesse. And then Alex, a couple of follow-ups on the age. So the first is, if the short oak was so old, how old are the big ones? And then another, when you said 800, it's really 800 years to
800, yeah, not a typo. I mean, that's a hypothetical aging, right? So that's taking the growth rate that we calculated from the actual seedlings and took that growth rate and then how long would it take at that growth rate to reach 2 meters? So that's a hypothetical age. That should be pointed out. So if those trees, well, we don't know what pre-settlement growth rates would be, right? They may have been, certainly in some areas, they would have been closer to that partial second study that we did where growth rate was much more rapid, and under average conditions, it would take an oak 20 years to clear that browse height. I think a lot of times we have to remember that these are no longer natural systems that we're working with. We have climate change, we have introduced annual grasses, we have a totally different grazing regime, a totally different fire regime. So when we think about restoration, this is one of the things, like when people are saying, why do you have to do weed control? Why do you have to do irrigation for plants that are supposed to be native? We're trying to force these plants to live right where we're telling them, versus like a management change, which would allow for them to pick and choose where they want to be. The aging of mature oaks happens typically at breast height is where they do the cores. So any of the growth that's happened from the ground to breast height is not accounted for. In the past, they've figured 50 to 75 years, so it's probably not too far off the aging of mature oaks, but it is not uncommon for a blue oak to be 300-400 years old. The lab at the University of Arkansas, where we did the dendrochronology, they specialize in blue oaks, and certainly as far they're currently looking at blue oaks as predictors of atmospheric rivers and how that might have implications for California's stormwater calculations, and they're measuring trees that are 400 or 500 years old.
Oh, that's fascinating. So with that, we're at time. So thank you, Jesse and Alex, and thank you for everyone who attended and asked questions and for your comments. Have a great rest of your day.
Thanks, everybody.